All right, let's get some math in here. Go ahead, get them. Find them all. Do the problem, 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 do the problem. Okay, now we're good. Yay, we're paying attention now. Good job. Remember your fundamental theorem of algebra. It says find all zeros. Doesn't say how. It doesn't say what kind. It just says find them all. You got to figure out how many are there and how you're going to get there. Okay, got everyone else? 1, 2, 3, 4, 5, 6, 7, 8, 12, 16, 17, 18, 19. Yep. Cool. Callister, might not be a bad idea to just separate yourself now. We're still going. 1, 2, 3. I want to know what each of you know, not what both of you know. Bonus points. If. I say that as the phrase, not you're not actually getting extra credit. That doesn't exist. Ah. If I rearrange it like that, do you see it? Do you see the factorable forms? These are in quadratic form. I could factor it as x squared minus 4, x squared plus 1. Here I could take out an x, leaving a x squared minus 4. They now share an x squared minus 4, so I'll take it out. When I do, this is the stuff I have left. This part is difference of squares. This part needs to go to quadratic formula or complete the square. Be negative 1, 1/2, 1/2 squared, 1/4, 75, negative 3, 75 going to be negative 1/2 plus or minus square root of 3 over 2i. Whichever way you did. And these are plus or minus 2. Did anyone go by factoring route? All right. I had to put it up there just in case. Most of us are going to say there's a 1, there's a 1, there's a negative 3, there's a negative 4, there's a negative 4, and say, I'm feeling really lucky about 2. 2. Excuse me. 3. 6, 3, 6, 2, 4, 0. And say, I feel really lucky about negative 2. Again, getting x squared plus x plus 1 equal to 0. Since no one did factoring, we'll just get rid of that. So we now have, I'm guessing no one did complete the square either. Anyone? 1, 2 of you? Okay. X is negative b plus minus b squared minus 4ac all over to a. In there goes. My a, b, and c are all 1. getting x is -1 plus or minus 1 minus 4 is -3. Square root of -3 is square root of 3i. And then they're both over 2. Don't forget to write the whole thing and plus or minus 2. So, let's do this. Thank you. Thank you. Thank you. Okay. I'll be here all semester. Do you have the synthetic division? Do you have the correct quadratic after the synthetic division? Do you have the setup for either quadratic formula or complete the square? Do you have your final answer, including all 4 of your zeros, and then 1 as a floater for the I did the dumb? Like, I wrote this and then I just didn't put plus or minus on one of them. Or I have my 2's over here. They're in my work. I just didn't write them with my answer. That kind of stuff. Okay? Questions there? All right. When I did the factoring, can you follow it? Can you do it? Because, okay, Mr. Spear and I were talking about kind of Algebra 2 and our pacing here, because he's doing a pilot of the book we're probably getting next year right now. I was going to do this year, but last year I didn't even know if I was coming back, so I told someone else to do it. Most of you are coming up to pre-calc, if I remember my roster correctly, like a good chunk of you, 2/3 at least. So the factoring stuff, you got to be able to do it. Okay? We review it. Like, we will review all of this polynomial stuff. So if you're coming from Algebra 2 straight into pre-calc, you are in the best position you will ever be. If you're sitting at an A or a B in this class right now and you're coming up to pre-calc, you're going to get the same thing. You're going to be fine. Okay? Just know that factoring stuff, it comes up again. And because we've seen it in here, it's expected that I can just toss that at you and you know what's going on. Okay? We'll do a little review, but you got to know what's going on. The homework. I didn't have anyone ask. That's the wrong thing. Not you. You. Anything? 12? Okay.
I knew you were gonna say. I couldn't hear you, but it worked out good. I know, because, I mean, I didn't pay for about half your compliments. And like all your compliments. Well, I'm sore. What? How did you manage to do that? What the heck? Enough already. Enough. I think we can Candy Crush and start the day off though. Candy Crush, eh? Notes.
Come on, you. Taking forever.
Yeah. Run. Yeah. Hey, Jen, I have your eraser, by the way.
5, 6.
2 hours ago. Just early.
There we go.
It starts to smell. We're just experimenting.
There we go. One, 4, 7, 16, 12. Four. Recognize the quadratic form. If I see that, I know that those can all go together now. This was your homework. You should have already done this.
Okay, I thought you were in the...
By factoring. Okay. If I recognize the quadratic form, I take that stuff and put it together. I take what's left over here. You say this part factors into x squared plus 4, x squared plus 3. This has an x, 4x that comes out, leaving x squared plus 4. Follow it so far. You rearrange it so that I got my stuff I'm going to group together in their groups. You factor them almost as if they were separate. Because now I see that you got an x squared plus 4, and you got an x squared plus 4. So when I take it out, when I factor it out, I have an x squared plus 3 and a plus 4x. This one factors normal quadratic, x plus 3, x plus 1. I hope we're recognizing it by now. If that said x squared minus 4, I would say plus or minus 2. But because it's x squared plus 4, it just means there's i's in there. Set them all equal to 0. X is plus or minus 2i, negative 3, negative 1. Okay. When it comes time for the quiz tomorrow, if there's one to do by factoring, expect almost identical to this. Okay? Like the quadratic form is hiding in there. You just have to take these pieces over here and those pieces over here. It's like, how many times have you actually put together a puzzle? Do kids even do that anymore besides with grandma? Okay? Like, don't you organize it before you start trying to figure stuff out? Like, go find all your edge pieces. If there's a sky in the picture, put all of your blue stuff over there. Like, you organize it before you start working on it. Okay? All right. Besides the factoring one, that was the only one that anyone asked me. You can do any of these polynomials by guess really good.
Look at you.
Synthetic division till you hit quadratic formula. $28. Number of complex roots. It's a cubic. 3. Like, that's what the fundamental theorem of algebra is. They say complex roots because every number can be written as a complex number. Like on that last one, I had plus or minus 2i, -3, and -1. If I write each of those as a complex number, well, that's 0 plus 2i, 0 minus 2i. That's -3 plus 0i. That's -1 plus 0i. They're all complex numbers. So that's why they say, what complex roots do you have? Because it covers all of them. Kind of like you ever have someone try to argue with you, like really, really particular, they mess with your words, and then you have to go back and change it to this broad umbrella term. Or maybe you argue with your parents like that. No, you will be home by 10 o'clock. But there's daylight savings time tonight, so like when exactly do we move the clock back? Or like, are we meeting 10 now or 10 then? Or what if I left where I was at 9:30, but it happened to be in the central time zone because I drove somewhere, and then I came back, and then they're just like, if that thing right there says 10 and you're not home, you're dead. Okay, you ever have that point where you just have to have this big umbrella term? You have to change the terminology and get specific about it. They say complex roots because complex roots covers everything. That is the do that or die. Okay, so possible positive real roots. It's the Descartes theorem thing. If they say just possible real roots, well, it's whatever the degree is. Possible rational roots, that was a rational root theorem. Okay. You're supposed to be using rational root theorem and Descartes to narrow down your choices. Before the advent of the graphing calculator, that's how we had to do it. Okay. Like the TI-83s that some of you had, some of you might have still, that's what came out when I was in high school. Okay. I graduated 2003. That's the brand spanking new calculator that they had in my Algebra 2 class. Okay. So we've had graphing calculators for plenty of time. We've used it like that, but what happened before that? You would have to do rational root theorem, Descartes' law of signs, guess and check until you find something that works. That's how you solved these. Okay? I'm just helping you speed up the process. But 28 was just tell me about the zeros. I don't think you actually had to find them. You were just telling me about the possibilities. Which is why if it didn't come out nicely, if it didn't solve with nice numbers, that's probably why. You're just supposed to describe the possibilities. Okay? Describing the possibilities, not what's actually going to happen. I could drop some real life talk on you, but I'm not allowed to as a teacher. No. So, no, I've been told not to do that anymore. So, y'all got good at this whole multiplying thing. Expanding out binomials. Y'all got it? We're there? Okay, what's anything to the 0 power? Just 1. That's it, just 1, right? If I only look at the coefficients, well, it's just a friggin' 1. Okay. If I have something to the first, it is itself a plus b. What are the coefficients only? Coefficients. 1. Okay. Do you remember the trick for expanding a binomial squared? Instead of foiling it out. No, that's freshman math right there. It was a question. You square the first term, square the second term. Right there is freshman math. And then you have to remember that I'm going to have A times B and B times A. So in the middle, I will have double their product. That was a question. Okay. And then coefficients. 1, 2, 1. So if I said A plus B cubed, what I'm doing is taking A plus B times A plus B squared, right? Y'all got some room off to the side, maybe the section right above that. Just find, don't use this page, we're going to use it. Somewhere above that, just scribble out, I would like you to multiply out. What is A plus B times A squared plus 2AB plus B squared? Find it.
Okay.
Multiply it out. Figure it out. Oh, missed that. There we go. Paying extra special attention to your exponents. Take A plus B times A squared plus 2AB plus B squared. Distribute it out. I'll write it down here, but I'm going to erase it. A plus B times A times the stuff is A cubed plus 2A squared B plus AB squared. B times the stuff is BA squared, so, B times the stuff is 2AB squared. B times the stuff is B cubed. Okay, so you got to be careful about all of your exponents here. And we get A cubed plus 3A squared B plus 3AB squared plus B cubed after I combine like terms. If I were to only look at my coefficients, I need to kind of have a dividing line here. If I only looked at my coefficients, they are 1, 3, 3, 1. So if I have A plus B to the fourth, would you agree that you're taking A plus B squared times A plus B squared? Or the entire A plus B cubed expansion times another A plus B? It's going to take a while, isn't it? How am I able to take it directly to, oh, wait, back that up. A to the fourth plus 4A cubed B plus 6 A squared B squared plus 4 ab cubed plus b to the fourth, getting coefficients of 1, 4, 6, 4, 1. How do I just know that's going to happen? There's some famous dad dudes, okay? I want you to look at the coefficients off to the side and start looking at diagonals. What if I told you the next one is going to be 1, 5, 10, 10, 5, 1? Do you start seeing what's happening in that little triangle? It is called Pascal's triangle. Pascal's triangle says if I take 1 plus 1, I get 2. 1 plus 2, I get 3. 2 plus 1, I get 3. 1 plus 3, I get 4. 3 plus 3, I get 6. 3 plus 1, I get 4. 4 and 1, 4 and 6, 6 and 4, 4 and 1. I always take the two numbers above it and add them together to make the number. Now there's a bunch of fun stuff that happens in Pascal's triangle, and it leads us into an entire different branch of mathematics called discrete math. In discrete math, just an entire new branch of mathematics. I was back there like, no thank you. He even like did the head bob like there was a tood with it. That was great. Don't worry about it. It's right there.
Told you.
Okay. Pascal's triangle goes forever. It is infinite. But it has some fun things in it in discrete math that lead us to combinatorics problems, the binomial theorem in terms of combinatoric probability. There's the hockey stick numbers. There's different powers hidden in here. Like, for example, what's 2 to the first? What's 2 to the second?
4.
To the third?
8. I'm sorry.
To the fourth?
32. 64. 128. 256. You want me to do one? I can't. 5. 12. 1. Yo! What the sussy baka? What is this? Who got you smiling like that?
Okay. 9. The sum of each row of Pascal's triangle is a power of 2.
What's the bottom one? That one? Alright, 1, 2.
2 to the 16th. Because, you notice, wasn't this 2 to the 4th?
Yep.
2 to the 5th?
Yep.
2 to the 6th?
Yep. I'm gonna do it in my head real quick.
So the nth row of Pascal's triangle has a sum of 2 to the n. Let's go further. What's 11 to the 0? What's 11 to the first? What's 11 to the second?
121.
What's 11 to the third?
It's 1331. Wait, 1330. Oh, it's right there. 1, 3, 4. Whoa. 8. Whoa. And then it's
What? What's 11 to the fourth?
14,641.
Now, after that, because of the way that place value system works, it kind of breaks down. But Pascal's triangle has, these are just a few things, okay? There's a lot of fun stuff. Like, have you ever heard of different number-based conspiracy theories? Not like, you know, drink bleach and take, you know, horse dewormer and now you'll have an immune system. Idiots. Instead, number-based conspiracy theories are things like the number 23. The number 23 has entire societies based on it. Because if you look for the pattern enough, you can start adding together the letters in people's names, and it comes out to 23, or you add up the digit place value of their letters in their initials, and it comes out to 23, and then this specific event that happened in history was on the 23rd day of February 3rd, or like the 23rd hour of February 3rd, or something like that. Like, there's all of these ways that you can start to look for patterns within events, within numerology, and you start saying it's all 23. It's all 23. Okay, the meaning of life. Hitchhiker's Guide to the Galaxy. It's a book. Something Earth destroyed, people go out into space, meet aliens. Aliens are like, here's the hitchhiker's guide to the galaxy. This is how you're going to survive being out in space. And they say, well, if you know everything, you're so smart, what's the meaning of life? They say, it's 42. They're like, why? Isn't it obvious? Haha, humans are stupid, and then just move on. And they never actually explain it. It's a nerd thing. But if you care for a mind-bending movie with someone that you didn't think that would play that part, the number 23. Just go look for the movie, the number 23, Jim Carrey, in a completely dead serious role, and it's a psychological thriller of him going crazy with the number 23. It's an amazing movie. It's horribly inappropriate for school. Don't watch it here. But it really starts to, it goes into numerology, but also does a decent depiction of someone who has psychosis, like actually has a break. So, anyway, Pascal's triangle, pretty cool. But that's how I make it. I just keep adding the two above it to make the thing that's diagonal. The way I'm going to use it is I get to use this to expand out binomials without having to do all the multiplication. Okay, so here's Pascal's triangle. You're probably going to have to keep flipping back to it. Here we go. Using the expansion of Pascal's triangle, I can take a plus b to the 6th. Imagine having to multiply that out longhand. That's a plus b times 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 a plus b.
Yep, that's right.
You would have to multiply these two, multiply those two, and multiply those two. And then you would multiply these two quadratics into a quartic, and then multiply by this quadratic. I'm throwing like math gang signs, right? Okay. It would take a long time. But with Pascal's triangle, what I'm going to do is say, since this is a 6th expansion of a thing, I hate that word, I'm going to go to the 6th row of Pascal's triangle. And I'm going to write down those coefficients with a bunch of parentheses after them. Okay? Wrong way. So, 1 parenthesis parenthesis plus 6 parenthesis parenthesis plus 15 parenthesis parenthesis plus 20 parenthesis parenthesis plus 15 parenthesis parenthesis plus 6 parenthesis parenthesis. I need to move this back.
Oh shoot, I
Eh. Plus 1 parenthesis parenthesis. Okay.
What the heck, man?
Maybe I'll use thinner writing to do it. I'm putting the same thing, I'm just putting it thinner writing. 1 parenthesis parenthesis plus 6 plus 15 plus 20 plus 15 plus 6 plus 1. Okay. So we're starting with, we've got all of these coefficients. 1, 6, 15, 20, 15, 6, 1. Okay? So I start with the coefficients. Why would I have all those parentheses up there? A and B. Now, if I take 6 A's and multiply them together, I get a to the 6th. We thought it, we didn't say it, right? So what's going to happen on the next term, though? If I start with a to the 6th, what's the next one? The next term. No. Descending order of polynomials. So I'm going to start by putting in a to the 6th, then a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, a to the 0. These are long. Okay? I'm not going to BS you about it. These are long. They're tedious. They're a lot of writing. But it beats multiplying them out. Okay? This is long and tedious, but that's like me saying, I want you to wash the dishes versus I want you to pack these dishes on your mule and take it down to Spearfish Creek, wash them in the creek, and then haul them home. Okay? It's long, but it could be worse. This is, sadly, the shortcut. Now, it doesn't make sense. I want you to go back to that first slide. Look at what we had for a to the 4th, or the a plus b to the 4th. What do you notice about the b's in it? The a's went 4, 3, 2, 1, gone. The b's were ascending instead. So next to each of these, I'm going to have b to the 0. B in the first, b in the second, b in the third, b in the fourth, b in the fifth, b in the sixth. Okay? So you start by write out your coefficients and a bunch of parenthesis butt cracks. I mean, when you got all the parentheses on there, it doesn't look like a bunch of little butt cheeks, right? Okay? So you're going to start with your coefficients and your butt cheeks. Then you plug in the first term in descending order. You plug in the second term in ascending order. Take a look at what the sum of the exponents is on every term. 6, 6, 6, 6, 6. That's how I know that I did it right. Because together, there should be a grand total of 6 terms being multiplied together. Then simplify it. 1 times a to the 6. 6 times a to the 5th times b. 6a to the 5th b. 15 a to the 4th b squared. 20 a in the 3rd b in the 3rd. 15 a squared b in the 4th. 6 ab to the 5th plus b to the 6th. Okay. That takes time, yes. But it beats having to do it by longhand multiplication. Just like that cheater formula I gave you saved you how much time with our polynomials, Pascal's triangle saves you 3-4 times that for expanding a binomial. Now there's applications of expanding the binomials besides just I need to multiply a bunch of stuff. In fact, it gets into probability. That's where true binomial theorem lives, is in probability of binomial events, meaning did it happen or not? Like, I know someone's batting average. What's the probability that they hit exactly 3 out of the 5 times they're at bat this game? Well, either they hit the ball or they didn't. Okay? So that's a binomial probability, yes or no. I can use binomial expansion to create combinatoric problems to just dump in formula. I can tell you the answer. Now that's later. We're not there yet. I would like you to expand to the 8th. Big oof. That'll take you a while. I'll be back. From the 6th row of Pascal's triangle.
But is that all of it? Like, the purple that? Yeah. And that's
Sure.
sick.
You're right.
Yeah. Greatest hits.
Let's go.
Just a bunch of freaking juniors, Chinese stuff.
Yeah.
Kid that much time. Crush.
Yay, nay?
Yeah.
Yeah, I am. I'm not going to flip back and forth when I have to do an entire screen. Okay, you write out your coefficients. Then you say a to the, starting with, eighth, a to the seventh, a to the sixth, a to the fifth, a to the fourth, a to the third, a to the second, a to the first, a to the 0 I don't need to write because it's just 1, with b to the first over here, b to the second, b to the third, b in the fourth, b in the fifth, b in the sixth, b in the seventh, b to the eighth, that. Okay? Now, so far it was just a and b. A to the fifth is just a to the fifth. B to the third is just b to the third. What happens when it's that? And then a to the third, and then a 56 in front of it. Do you remember your order of operations? PEMDAS, please execute my deranged adolescent sister. Parentheses come first. I don't have parentheses that I can simplify. Do I have exponents that I can simplify? Yes. So then I would turn that into my coefficient piece, my A term piece, and my B term piece. Then multiplication. Negative to the fifth. It's 5 negatives. And then I will smash all of that together to get negative big number a to the third. Okay? But think about this. We're looking at that and going like, don't wanna. But would it beat doing the long multiplication? Okay? It still sucks, yes. And this is one of those things where, hate to say it, you've got at least a 50-50 shot of seeing something with binomial expansion or Pascal's triangle on ACT. Okay? You do. What you're probably more likely to see is they'll say, what is the fifth term of this to the sixth? If you can off to the side quick sketch out the triangle like that, right? I can go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. I can get to my sixth row, go find my fifth term, and then I know that it's going to go to the sixth, seventh, or sixth, fifth, fourth, third, second. Okay, so 15, something to the second, something to the fourth. As opposed to multiplying it out all 6 times, combining like terms, and then getting to my answer. Okay? Sometimes the easiest it gets is still pretty nasty. So, let's try that. I want you to watch your signs with this. Okay? So, go to your 5th row. Fifth row is 1, butt cheek, butt cheek. 5, butt cheek, butt cheek. Then, was it 15?
No.
10? 10, 20, 10?
Nope. 10, 10, 5.
Oh, Samsonite.
Bruh.
Okay. Set that up. Plug in your a and b term with descending and ascending exponents. And can you simplify it correctly? Okay. I know that I'll have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. I know I will have negative 3 to the 0, negative 3 in the 1st, negative 3 to the 2nd, negative 3 in the 3rd, negative 3 in the 4th, negative 3 to the 5th. Where you have to be careful is this is 1 times this plus 5 times this plus 10 times this. Okay, I know that this is just x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and 1. But this part is 1, negative 3, positive 9, negative 27, positive 81, negative 243. Exponents come before multiplication. Getting x to the 5th minus 15x to the 4th plus 90x to the 3rd minus 270x squared plus 405x minus 243. And you have to be so careful with that, because what I'll see kids do year after year after year is they will take something like this and they'll do negative 30 to the 3rd. I will see kids break the order of operations on these. Now in this one, it's a little easier to not do that because the x is between the two numbers. But what happens if that's where I'll really see kids screwed up is it's 10 times 2x squared times negative 3 to the 3rd. I will see kids year after year after year say 20 squared is 400. 400 times negative 27. Okay, you have to watch your order of operations. And that's where you might not want to, but this middle line right here might save you from screwing that up. You're too young to get carpal tunnel, you'll be fine. Okay? If it prevents you from screwing up, it's worth writing it out. Which I believe is actually the next example. Ooh. It's a lot to write. Now I want you to think about the amount that I write normally versus the amount I'm writing now. Think about having those printed out notes. The reason that I have these note packets for you to work in as we're doing our examples is so you don't have to do exactly what Maria's doing right now, which is, no!
You can go now.
Wait. Okay. How many classes have you just sat there and just copied what's on the board for 90 minutes, and at the end of it, you have no idea what you wrote down? Because you're not learning it, you're not talking about it, you're not doing anything, you are just scrambling to stay caught up. Okay. All right. So, I'll show you again. I'm going to expand this out. How do I start? Where am I? Go in the triangle thingy, Pascal's triangle, and I go to the 5th row. Remember the very top where it's just 1? That doesn't count. That's like row 0. So I go to the 5th row, and I will write out all the butt cheeks. We'll say 1, parenthesis, parenthesis, 5, butt cheek, 10, butt cheek, 10, butt cheek, 5, 1. I always start with really big spacing at the beginning, and then about halfway through the board, I'm like, oh crap. And they just start getting smaller and smaller. So, okay. So I have to recognize that's a 3x to the 5th, a 3x to the 4th, 3x to the 3rd, 3x squared, 3x to the 1st, 3x to the 0. While I have blue, I'm going to write below that. What is 3 to the 5th? No, that's 5 to the 3rd.
3 to the 5th? It's very big numbers.
Remember when I said you should know perfect squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can get your hands on, because here it is, 243, x to the 5th. Here's a 81, x to the 4th. Here's a 27, x to the 3rd. Here's a 9x squared, a 3x, and a 1. 1 times plus 5 times plus 10 times plus 10 times. Why do people feel the need to sound like a Clydesdale? And we said that was 1. Okay. I'm also going to plug in my -2 to the 0, -2 to the 1st, -2 to the 2nd, -2 to the 3rd, -2 to the 4th, -2 to the 5th, which is -32, which is +16, which is -8, which is +4, which is -2, which is 1. Do you see how that second line can help so I don't screw up the exponent multiplication thing? Because again, I will see kids year after year, right here, they'll say 5 times 3 is 15, 15 to the 4th. Don't do that. Exponents come before multiplication. Then you clean it up and say 243x to the 5th plus 405, missed that -2, minus 810 x to the 4th. What's that? 454, 18, 1080 plus 1080 x to the 3rd minus 720 x squared. 15, 16, 225, 240 x minus 32. Okay. Imagine multiplying that out. All 5 binomials and going distribution bonkers on it. Okay? Drop the class. I don't care if I'm more than halfway through. Withdraw, fail, gimme. Which I have had kids do. Yeah, you can drop a class at any time with administrator approval, and then maybe they throw you in the cabin to work on your other classes. We do it with kids who are struggling in multiple classes, where we're like, okay, you got like a 40 in English, got a 50 in history, but you got a 12 in algebra. We're going to triage this. We're just going to take you out of algebra. You'll take the loss on that. You'll get an extra class to just work on your other stuff and salvage those credits. We have that happen, yeah.
Is that a multiplication sign between 1080 and 720?
Minus. It's a really tiny minus.
I forgot my black.
You need to swap spots with one of the goobers? You sure?
I can see most of it.
Okay. Yeah, this is like goof chirp right here. Okay. When, who was it? Algebra. Yeah, pre-calc, the class before. When I said, no, those 4 are in the first row, they're like, oh my God, I'm so sorry. So, yeah. So,
I bet they said yeah. Oh, you're so lucky.
all right. 2x minus 3 to the 4th. Get them.
Keep an eye on them.
There's days I wish I miss my bat. I used to have a foam bat that I'd whack kids with. I shouldn't do that, so I got rid of it. I can't be mad because it's my fault.
When my mom comes in my room tonight, she hears me going fudgy.
Yep.
You should have something about like if your kid had SAT and you just figure it just the other kids like.
That's what is wrong with this guy?
Oh my God, I can't get away.
Hey, you want to see my butt cheek? Sure. There you go. Just see how mine.
4, 3, 2, 1.
I'm getting on.
It's like my 4-year-old playing at home where he's just like, but, poop. To the ladies of the species, I apologize. We don't get any better. You can train us to behave in public, but social norms excuse so much horrible male behavior that this is as good as it gets. Okay. So we start with our coefficients and a whole lot of parentheses. Nope, not gonna do it. Nope. So we have
So bad.
so then we'll plug in 2x descending, 2x to the fourth, 2x to the third, 2x to the second, 2x to the first, 2x to the 0. Getting 16x to the fourth, 8x to the third, 4x squared, 2x, and 1. Plugging in a negative 3, right? Is it negative 3 next? 0, negative 3 in the first, negative 3 to the second, negative 3 to the third, negative 3 to the fourth, with 1 by. Okay. And then finish it off. 16x to the fourth minus 96x cubed. Right? All right. 24, 9, no. 36. Oh, yeah, it's 216. X squared minus 8 by 9, 72, 3, 216 again. I made a mistake and wound up the goof troop. Are those numbers actually right?
Yeah, those are. Right there.
Okay. Yes, no?
No, Chad.
Who said no?
I got that.
I got it.
Okay. So if we can argue about that, if we're not sure about the individual numbers, do you see where a lot could go wrong? It's not difficult. It's tedious. And when you got that many pieces moving, that many numbers floating around, it's really easy to screw stuff up. I have turned in kids' notes to our administrators before with different things in them. All right. And then part B, they're like, oh, hey, look, powers of 11.
No.
So, do you get it?
Yes.
I'm not asking if you like it. Do you get it? Okay. All right. What I want us to try. Okay. When they ask for a very specific term, I included this here because they don't have this in your book, but I guarantee it'll be one of the questions they ask in the homework. If I'm specifically asking for the second term of this, I do it piecemeal. Start with, go to line 8 of your Pascal's triangle. What is the second coefficient in line 8? 8 itself. So we're going to have 8, parenthesis, parenthesis. And then I always start with thing to the 8th, right? and then it goes down from there. So if I'm at the second term, what will the exponents be on these two? 7 and has to be 1 because it'll start at 0 and go up. Also, 7 plus 1 equals 8. It has to equal the expansion. Then plug in your two terms. Negative 32 x to the 7th. Okay? So, could you do this one? Get them. The fourth term of x minus 2 to the 7th. So 7th row, go to the fourth coefficient, write it, parenthesis, parenthesis, fill in your terms, fill in your exponents, figure it out. You don't have to do the entire expansion if they only want you to find the fourth term. This is likely the type of problem you'll see on an ACT.
See, look right here. I know, but it still equals the 6. So it has to be 3 and 4 because it can't be just 3 and 3. It has to equal 7.
Listen to Dawson. Okay. So, 7th row of the triangle, what is the fourth coefficient? If it's the fourth term, I'm going to start at thing to the 7th, thing to the 6th, thing to the 5th, thing to the 4th. What do I have to balance that out? That should also make sense because my second term starts at 0, then 1, then 2, then 3. My fourth term will have something to the third. Now it's just a matter of multiply it all out. I say negative 2 to the third is 8, negative 8. Negative 8 by 35, so 270, 470, negative 280. Okay. So that right there is very indicative of what you'll see in a standardized test. Because they're not going to make you do the entire expansion on, like, that's one problem taking up 10 minutes of your allotted 60. It doesn't make sense to have that. But if they said the fourth term of, okay, that's more reasonable. In fact, that's usually what I do on my quizzes. Instead of having you expand the entire thing, I have you go and find just this specific term. Because you still have to know what's going on to find it. You just cuts down on the amount of work. Can you do it when it gets ugly? The pre-SAT and the pre-ACT, they do send it back to you. Not just with your score, they send you your workbook back and the correct answers. They send you the whole works. The regular ACT, not so much. But the pre-ACT and pre-SAT, yeah, they do. They give you those back because they want kids to go spend money on all the prep programs now. Now that they know how it works.
This was 3 and 3. Yes. Right? You're right. Yeah.
3 and 3. Yes.
So you started at 6. X squared and then to the 4th. Just X to the 6th. Yo, what? X squared to the 3rd equals.
Exponent raised to an exponent, you multiply.
You're right, but I know I'm right. So.
How though?
Okay, I know x squared and negative 2y. Since I have the 6th expansion, 3rd term, I'll go to the 6th row, 3rd coefficient, which is 10? 15? And then, because it's a 3rd term, I know that I'm going to start at something to the 6th, something to the 5th, something to the 4th.
Oh, you know what?
And because they have to add up to 6 for total exponents, 2. Also, personally, I find it easier to count from 0 upward instead of backwards. I say 0, 1, 2. Look, 3rd term. So I'll put something to the 2nd and then subtract to find the other one. Everyone's got a preference. Now that I'm here, it's 15 times x to the 8th times 4y squared is 60. X to the 8th y squared. Okay? Y'all good? All right, we don't need to do any of the others. We're good. Let me check that the assignment's decent.